Hello, today we are going to learn new concepts for describing a relation of a function. And one is domain. Domain means valid input for a relation. So normally it will be the x. All the valid x, we call it domain, okay? And for the range is a valid output. Okay, so we'll give you valid output, the value that can take for that relation. And sometimes you may confuse which one is for x, which one is for y. Just look at the initial letter. This is D, this is R, so it's just alphabetical order. Alphabetical order. So x is at front of y, so D is at front of R. So you just compare. Oh, the domain is at front of R, so domain is for x, range is for y. And the independent variable represent the input, and the dependent variable represent output. Okay, and here we have list number system. And don't worry about so many letters here, because you just need to know the R. So we write it this one. It represents a side of number side of real numbers. Number side of real number. And the real numbers are the numbers on the number line. So the numbers on the number line, we could represent them with real numbers. And the several special numbers, we gave them other names as natural number, which means countable number 1, 2, 3, 4, all positive integers. And the whole number means all positive integers plus 0. Then set of integers means negative, 0, and also positive integers we call whole numbers. These two rational numbers means fractions. As long as you can write a number in fractions, both numerator and denominator are integers, then we call it rational numbers. All the numbers that couldn't be written as a fraction, so then we call it irrational numbers. Irrational numbers, you have thing before is some square root and also the pi. It means there's no ending. If you write it as decimals, no ending. Okay. And like I said, don't worry about all the number side. You just remember, okay, R means the number side of real number. Real number means all the numbers on your number lines. Then it's okay. Okay. So we are going to practice on finding the domain and the range from given graph. So domain and range, domain means valid x input. So it means you are looking for the valid x values on the graph, okay? So this graph is from here and in here. So your task is finding the x minimum value and also maximum value. So on the left of your graph is the minimum value of x. On the very right side of your graph is the x maximum value. And your domain, you could write it as minimum x less than or equal to x less than or equal to max. Okay, so your x value should be between the minimum and maximum value. So your task is finding the very left side of your graph and very right side of your graph on the xy coordinate system. So the very left is your minimum. So this one we read it from the graph is -1, And the maximum, we read it from the graph, is 5. So for the valid x value, it means between the negative 5, 1 and 5. So we are going to write it as this way: minimum less or equal to x less or equal to 5. When you have a solid dot, it means we are going to write equal sign there. So that is for your x value. And for the y value, the valid y value will be the minimum and the maximum y value. The y is between them. So for the minimum of y is for x is left, right, and for the y is up and down. Okay, the very low point on your graph to the very high point, the highest point on your graph. This is your y maximum, and the lowest point on your graph is your minimum of y. So this one is -2, this one is +1. So what you are going to do is just substitute minimum here, maximum here, then write less than or equal to y, less than or equal to max. Then it's done. And one more question is it a function or relation? So use a vertical line test. So we put a vertical line anywhere and see how many point of intersections you will have with a given graph. You will see you move this line anywhere, you will have maximum 1 point. If you move outside of this graph, then you will see there's 0 point. It means here you have no valid input. Okay, so this is yes, you have only 1 point of intersection. And for here, if we have x equals 7, you will see no point here, so y is none. Then this one means these are x equals 7 is not a valid input, so that's the reason x less than 5. If beyond 5, we don't know what happened to the graph, so we don't know how we can find the y value from that one. Okay, then we don't call that outside of this graph the valid input. Okay, so for this one it's different from the last one because you will see you have arrows on the graph. It means keeps going. Okay, it won't stop. So for the x, the very left, no ending is called negative infinity, and for the right keeps going, no ending, call it positive infinity. So the domain, we are going to write it as negative infinity less than x less than positive infinity, and when it happens, we don't write equal sign here because the infinity means you are going to never ever reach it. And I want to show you another notation for this set notation for this interval notation. Okay, I want to show you another interval notation to write this domain range. This one we call inequality notation. Okay, so that one we'll write it as negative infinity to positive infinity and put bracket at each end. So bracket, this one means doesn't include the negative infinity or positive infinity. And for this one in interval notation, we could write it in this way. So for the x, it will be -1 to +5, and because you have equal sign, we use squared bracket. And for the y, the range, we are going to write it as -2, +1, and squared bracket. So write the minimum on the left, maximum on the right. So for the range, we are going to see the minimum for y is the lowest point is -4 maybe 4.4. Okay, And the maximum is keeps going is positive infinity. So we are going to write minimum is this one and is solid, and maximum positive infinity, you are not going to reach it, so no equal sign. And for the interval notation, we are going to write negative 4.4 squared bracket, then positive infinity. Okay, this interval notation you may need it for the data math, because some of the data math question will ask you to write in the interval notation. Okay, and for this inequality notation, also you could just write y is greater than or equal to negative 4.4. You don't need to write negative infinity, or you could write another way, okay? Less than or equal to y. You don't need to write infinity there. If other side, you could keep it open, means it keeps going, okay? And for the function, is function or not function? So use int vertical line test, okay? You just draw a vertical line anywhere, you will see only one point of intersection, so it is a function. Then the next one is tricky. It's not a continuous lines. It means this one is discrete data. So for discrete data, we are going to write the domain just by list all the valid input. So this one is -3, -2, x -1, 0, x equals 1, x equals 2. So x is from -3 to +2. Just list all the valid x value, that is okay. For the y, we just list all the valid y values. So -1, 0, 1, 2, 3, 4, 5. So from -1 to +5. That is done. Okay. That is how you write the domain and range out. So we are going to the next page. So this is the next page, and for this one, we are going to find the minimum of x. That is very left. Will give you the minimum of x is -5, and on the very right side, okay, will give you the max of x. So this is left, right. This is the left, right, give you the minimum and the maximum of x. This one will be around 10.5 maybe. So now we are going to write, okay, -5, 10.5. Then because it's open dot, means not equal, then less than or equal to this one. So for interval notation, you are going to write open, it's just a normal bracket, and the right side we have a squared bracket. So for the y value, you will see it's a little bit tricky. You only have two y values. So this is 5.5. So you just write y equals 2.2, 5.5, list them, then it's okay. And for this one, is a function or not function. You are going to draw a vertical line here. You could draw a vertical line other places. You will see only have one point of intersection. But if you draw a line here, it's tricky. You have one point intersections, and if it's open dot, means that point doesn't include. So you have only one point of intersection if you draw this line here. So it is yes. If you have another graph, solid dot, stop here, and another one, solid dot here, then you have 2 points of intersection, not a function. But for this question, you have one dot solid, one open, so it is a function. So next one, find the left, very right, that is your maximum, minimum for x. So it's -5, +5, so right, -5 less than equal to x, less than or equal to 5. There's no open dot, it's included. It's included with that point. And for the y, it's the lowest point, and the highest point is -5, +5. So it's minimum -5, maximum +5, no open point, open dot, so it's equal. Or you could write it as interval notation, so it's -5 squared bracket because you have equal sign. This one squared bracket, comma, then 5. Okay, and let's see if this one is a function or not function. We just draw a vertical line at anywhere. You will see you have 2 points of intersections with a given graph, so this is not a function. Okay, so we are continue to the next one, and remember, put arrows at each end means the graph keeps going, so they are quadratic parabola graph. Okay, then we are going to look for the minimum and the maximum. So this one got arrows means very left, very right, keeps going, so you have -infinity, +infinity there. And if you write it as interval notation, it's -infinity, +infinity, no squared bracket. And for the y, you do have one lowest point is 2.5, and the maximum is nothing, it's infinity. So it's 2.5 less than or equal to y less than infinity. Interval notation, squared bracket includes 2.5 and +infinity. For this one, keeps going left, right, so it's -infinity, +infinity for x. Interval notation is -infinity, +infinity. For y, you have a lowest point, that is minimum. And for the y, maximum keeps going, is +infinity. You don't need to write positive. So this one is -1 and +infinity. And for the delta max, sometimes it may just read this way. It's okay, you don't need to write the +infinity for that part, but write that one here is correct. So this one is left, right, keeps going, so -infinity, +infinity, less than x, less than x. So this one opening, this side, open side is larger number, okay? It's less than this sign. And this one is 5, and the lowest point is -infinity. So we just copy this one less than, this one is less than equal to. And the interval will be notation is this way, this one -infinity and -5 squared bracket. So that is all for this lesson, and do the assigned work on delta max.